7 miles below the Pacific Ocean, there's a place so deep, dark, and pressurized that humans were never meant to see it. Yet in 1960, 2 men went there anyway. What they found at the bottom of the Mariana Trench changed how we understand our planet, and proved that even Earth's most hostile environments are not as lifeless as we once believed. In 1872, a British research ship called the HMS Challenger set out on an ambitious mission. Its goal was simple but groundbreaking for its time: map the ocean floor. Back then, scientists believed the deep ocean was mostly flat, silent, and biologically empty.
Level, the sea was pretty flat, pretty dead, fairly lifeless.
The idea of underwater mountains, valleys, or trenches barely existed. Most depth measurements were made by lowering rope and heavy weights into the water, a slow and exhausting process. For 4 years, the Challenger traveled more than 70,000 miles across the world's oceans. Crew members dropped weighted lines every 100 to 150 miles, carefully recording how much rope it took before the weight hit bottom. When the ship reached waters about 200 miles east of Guam, something unexpected happened. The weight kept sinking and sinking and sinking. Eventually, it struck bottom at roughly 4.5 miles deep. No one had imagined the ocean could reach that depth. That single measurement sparked a mystery. Why was the ocean floor so dramatically different here? The Challenger expedition produced the first rough map of the ocean floor. It revealed something astonishing. Near continents, the seafloor slopes gradually downward. Then it drops into massive flat plains. But in the western Pacific, the pattern changed dramatically. The bottom plunged even deeper into what appeared to be a giant scar in Earth's crust. For decades, scientists had no explanation. The tools simply weren't advanced enough. That changed in the early 20th century with the development of sonar, originally designed to detect submarines during wartime. Sonar used sound waves to measure distance underwater. By timing how long it took sound to bounce back, researchers could create accurate maps of the seafloor. In 1951, a British research vessel returned to the mysterious Pacific site using sonar technology. What it discovered transformed ocean science. The hole wasn't a hole at all. It was a massive trench stretching about 1,500 miles long, roughly the length of California. Its depth dwarfed nearly every known geological feature on Earth. At its southern end lay an even deeper point now called the Challenger Deep. This was the lowest known place on the planet. To visualize its scale, imagine dropping Mount Everest into the trench. Even the world's tallest mountain would still be covered by about a mile of water. The depth is also far greater than the height of the Empire State Building, stacked dozens of times. But one question remained: how did this trench form? Scientists realized the only way to truly understand the trench was to see it up close. That meant sending humans to the deepest point on Earth. The challenge was enormous. At the bottom of the trench, pressure reaches around 16,000 pounds per square inch. That's over 1,000 times greater than at the surface. Humans could not survive those conditions without protection. Engineers needed a vehicle strong enough to withstand crushing pressure, yet light enough to descend safely. In 1953, Swiss scientist Auguste Piccard designed a revolutionary deep-sea submersible. It featured a large buoyant structure filled with gasoline for lift and a small steel sphere underneath where the crew would sit. The sphere was only about 6 feet wide, with steel walls 5 inches thick. It was built to resist the immense pressure of the deep ocean. After years of testing, the vessel was ready. In January 1960, a secret mission launched from Guam On board were U.S. Navy officer Don Walsh and engineer Jacques Piccard, son of the submersible's designer. The operation was backed by the United States Navy, though few people knew it was happening. The risk of failure was high, and success was far from guaranteed. Inside the cramped sphere, Walsh and Piccard began their descent. The space was tiny, about the size of a household refrigerator. Temperatures were cold. There was little room to move. Outside, the water grew darker and colder with every passing minute. At 3,000 feet, sunlight vanished completely. The only illumination came from the submersible's lights and occasional flashes of bioluminescent creatures drifting through the darkness like underwater fireflies. Hours passed as they sank deeper. Then, at around 20,000 feet, disaster nearly struck. A loud bang echoed through the cabin. One of the outer window panes cracked under pressure. The inner pane held. If it had failed, the water pressure would have crushed the sphere instantly. Despite the danger, Walsh and Piccard continued downward. After nearly 5 hours, the submersible approached the ocean floor. Suddenly, movement appeared below them. A flat fish swam across the seafloor. This was shocking. Scientists had assumed life could not survive such pressure and darkness. Yet here was clear evidence that organisms lived at the deepest point on Earth. Moments later, the submersible touched down. Their depth gauge read approximately 35,800 feet. Nearly 7 miles beneath the surface. For the first time in history, humans had reached the bottom of the Mariana Trench. They were closer to the center of Earth than any people before them. Inside their tiny sphere, Walsh and Piccard took photos and recorded observations. However, the landing stirred up fine sediment, creating a cloudy underwater haze that limited visibility. After about 20 minutes on the bottom, they began the long journey back to the surface. The entire mission lasted roughly 9 hours. Later scientific discoveries revealed how the trench formed. It sits at a boundary where one tectonic plate slides beneath another in a process called subduction. Over millions of years, this collision forces the Earth's crust downward, creating a deep trench. These zones are among the most geologically active places on Earth. They generate earthquakes, volcanoes, and massive underwater landscapes. The Mariana Trench is essentially a scar created by the slow but powerful movement of Earth's plates, and it continues to evolve today. Perhaps the most important discovery from the 1960 dive wasn't geological. It was biological. Life existed where scientists once thought it was impossible. In the decades since, robotic missions have found bacteria, crustaceans, and strange deep-sea organisms thriving under extreme pressure and total darkness. These creatures survive without sunlight, relying on chemical reactions and organic matter drifting down from above. Their existence reshaped our understanding of where life can survive, even raising questions about life on other planets and moons. If organisms can live in Earth's deepest oceans, they might also exist beneath icy surfaces elsewhere in the solar system. The 1960 descent remains one of the boldest explorations in human history. Walsh and Piccard proved that humans could reach the most extreme depths of the planet. Their journey opened the door for modern deep-sea research and inspired generations of oceanographers and engineers. Even today, the Mariana Trench is still largely unexplored. Vast portions remain unmapped, and countless species likely wait to be discovered. We know more about the surface of Mars than we do about Earth's deepest ocean. That alone says everything about how mysterious our own planet still is. It is not just the deepest place on Earth. It's a reminder of how much remains unknown beneath our feet and beneath our oceans. From a rope dropped into the sea in the 1800s to a daring dive nearly 7 miles down, this journey reshaped science and challenged human limits. And the story isn't over. Every new expedition reveals more about how our planet works, how life adapts, and how much we still have to learn. Because sometimes, the greatest mysteries aren't in space. They're right here on Earth, waiting in the darkness below.